Welcome to this Frequency Matters podcast. I'm Pat Hindle, and I'm talking with Brandon Branham, Assistant City Manager and CTO of PeachTree Corners and Executive Director of the Curiosity Lab, and also Brad Stertz, Director of Audi Government Affairs. Welcome, guys.
Welcome. Thank you.
Thanks for having us.
So I saw a big news item that PeachTree Corners and Audi of America, are announcing a collaboration to advance cellular vehicle to everything, or C-V2X. And this is for practical deployment pathways as part of the city's Curiosity Lab ecosystem. I see that both Audi and PeachTree Corners are having this opportune time to deploy C-V2X applications, and this will allow vehicles to communicate with city-owned streets, traffic signals, crosswalks, and other infrastructure, as well as the vulnerable road users. So it's a big safety issue here. So can you give us a little bit of background on the project?
Yeah, I'll start with that one. Over the last few years, we've really been taking an initiative to do what we can from the City of Peachtree Corners side through the work with Curiosity Lab to bring connected vehicles, to public infrastructure to really start managing the opportunities around safety that connected vehicle applications can bring to drivers and roadways and most important, vulnerable road users. So we started that initiative a few years ago, originally with DSRC, and then transitioned to C-V2X as the FCC started to transition as well. And then really, went in on the infrastructure to make sure all aspects of the city's infrastructure were connected and able to broadcast safety messages out to vehicles. And then fast forward, after a couple of years in conversations with Brad, and just really saw a great opportunity as the incredible work he's doing to push us through from the OEM side to come together around that focus on vulnerable road users, because in the past they had traditionally been kind of overlooked in the deployment of DSRC. In the beginning, it was really about the infrastructure, and now there's opportunity to really take and connect those that were previously unconnected.
Okay, so maybe you can tell us a little bit about how these Audi vehicles will communicate as they're driving around and what they'll communicate with and how that works.
So I can explain that a bit. So the cars will be equipped. They're not currently equipped, and in fact, we're waiting for the Federal Communications Commission to finalize its work on all of the requirements around the safety spectrum in the 5.9 gigahertz spectrum. But when this gets cleared up, and then as production plans move forward, cars will have a radio that can connect to anything else that has a C-V2X radio installed. And that can include everything from a bicycle, pedestrian, or infrastructure, as Brandon was mentioning, and of course, other cars and other vehicles on the road. And we see this really, we're at a cusp of having true safety communications, but also a lot of improved quality of life opportunities with this ability of traffic to interact better with its environment.
So maybe you can tell us a little bit about the device used, for cyclists and pedestrians. What does that look like and how does it work?
So I think that the nearest opportunity is a device for cyclists. It's about the size of a mobile phone that can transmit a signal of here I am and see you, see me back and forth to the car 10 times a second and, to the bicycle. And especially this is important in areas where there's very poor line of sight, either in, places where there's tall buildings or other obstructions or curvy roads and that kind of thing, to give the motorist a sense that there is something ahead that you need to be prepared to drive more cautiously with. So this will also eventually come to pedestrians. It's not quite there for mobile phone integration yet, but that's being worked on by the mobile device industry and the chip makers. But it's something that I think is down the road very possible once this also gets installed in the vehicles.
And so it will warn the vehicle that, it's getting near, or how does that work? Is it automated or is it just kind of a warning?
It's automated, so the car is able to detect that there's a bicycle ahead, or for instance, if the motorist or an automated vehicle is attempting to change a lane or pull out of a parallel parking spot, it will detect that there's a cyclist coming alongside to be more cautious about. And so it's truly like a radio signal that's sent back and forth 10 times a second to the car and the vulnerable road user.
And so I can imagine there must be a lot of challenges in designing a system like this. What are the main things that you have to overcome to have an effective safety system?
Well, there's a couple of things. One, now that we're getting clarity on spectrum use, and you have this opportunity with C-V2X to operate in the safety spectrum where there's very low latency, very accurate communications in a very dangerous situation, so that the car is able to maneuver or brake properly. And you also have the opportunity with C-V2X to utilize mobile networks for more safety enhancing longer distance communications, so that the car or the motorist can stay away from danger to begin with. But the obstacles are, first of all, once we get clarity in the spectrum, is to begin to build out the ecosystem, and that's where our excitement to work with PeachTree Corners is really a progressive leader in this area, wanting to get prepared for the future. We want to be able to advise and work and get everything in place so that it can be something that's very effective when the cars start to arrive in quantity. The other challenge on a practical level is, what do you do when there's a dozen bicycles or 100 bicycles, or in a place like some of the major cities in China, thousands of bicycles? And that's where we have to be very careful about not overstimulating the driver or bombarding them with alert messages, but rather maybe give them something that's more akin to sort of a heat warning that they're approaching an increasingly dangerous situation and they need to take better care. So this sort of human and machine interface question is something that we want to work on in the next few years as we move towards production.
Piggyback on that is kind of that transition, to get to where the end state we want it to be, where we're all connected and every person and device is out there and is seen by, vehicles and pedestrians see vehicles. But there is a kind of in-between step that the local governments and state, governments and counties have an opportunity to start to use infrastructure in a way to meet that middle gap, using things such as LiDAR to detect pedestrians and crosswalks, and then converting that to a C-V2X message so that we can broadcast out to vehicles. And then, as Brad mentioned, we have to work together in this spectrum of it, because of the amount of messages that can be sent out are almost infinite. But what makes the most sense to have the most awareness for the driver so that they do pay attention? And I think that's where we see a great opportunity with Audi and others in this space to really start to define that, so that when we do get to where we want to be, it's ideal for the driver and the user.
Well, that brings up another question. How do you connect all the infrastructure like traffic lights, that don't already have a cellular connection in place?
So that goes back to a little bit of what Brad was mentioning, the two different types of communication, where you do have that millisecond with a roadside unit. So cities and other local government agencies can deploy roadside units on their infrastructure, and that broadcasts out information of what's happening in the intersection, the phasing of the signal itself. So that is here. We can get those products today. Obviously, still some areas to be determined by the rules and the bandwidth from the FCC, but that's how local government starts to implement connected vehicle technologies, is through that roadside unit. And then they can also start to implement some of the onboard units inside of their own fleet vehicles. We're seeing that here. Brad did a great project in Alpharetta with the school bus system and a connected vehicle, because people run school bus, stop arms all the time. How do you start to prevent those types of things and also improve efficiency of school buses, giving them green lights so the bus schedule stays on time? Those are things that we can do today and build upon what's to be in the future.
That's great. So maybe if you could just tell us a little bit more about the hardware, and if there's any special software that's needed, what is needed on the car or the bicycle Or I understand on the person it would be part of the phone, which would be really convenient. And is it applicable to other things like skateboarders or other types of way that people are moving around?
Well, I'll start from our side, and then maybe Brandon can add from the infrastructure side. So it's literally a radio module. It's not extraordinarily expensive to install a car, even though in most cases when you're designing a car, you're looking for nickels to save um, on the cost, but it's not ridiculously expensive. And it's just literally like a radio that sends out a discrete set of messages that are understood at the other on the receiving end, whether that's another vehicle or traffic signal. I will note I helped co-author a study or a report by ITS America that estimated to equip about 75% of the nation's signalized intersections. So in the ballpark of 220, 230,000 traffic signals. Total cost over 10 years to build that out would be about $7.5 billion. And while that sounds like a lot of money, when you're spreading that over the entire country and over 10 years, it's not that daunting of an investment, particularly at a time when the infrastructure bill that is providing unprecedented amounts of money for infrastructure improvements. So we're really hopeful that cities can begin to look to this and install it, and so that the cars will be able to interact better with the traffic signals at a minimum. And just to give you some examples of the applications there, and Brandon touched on this, Fulton County schools in Georgia found that because the equipped school buses received signal prioritization, kids were getting to school on time. Kids who qualified for a hot breakfast due to their economic conditions were able to get to school on time and actually have a good start for their day and a good breakfast. And the school district realized it was saving 10 to 12% on fuel costs because the buses weren't idling at stoplights. So it's the kind of thing that almost begins to start paying for itself in that way if you begin to deploy this more broadly. And for things like emergency vehicles, it can make a critical difference in time getting to hospital or medical care, because you can imagine that traffic intersections would be able to get cleared out if if the traffic lights know how far away the ambulance is away, and how far when it needs to start getting cars cleared out of the intersection. So there's a lot of benefits like that, and that's where I think we as an automaker and Peachtree Corners as a really motivated municipality can begin to work on some of those applications.
Yep. So as you kind of heard there, Patrick, was it does take both sides. You do have to have the broadcasting radio, and that's what, the cities are. That's really where the local governments come in from our side, is making sure the infrastructure is connected. And then you have to have that receiving radio to receive those messages. And that's going to come in different form factors. As Brad mentioned, the radio in the car, the work we're doing with Spoke, as Brad hinted a little bit earlier about the size of a cell phone, where you can, we currently did a deployment demonstration of that at a Criterium, where we put about 10 bicycles on the connected device, and we could see all of that in trans and receive messages from them. And then we're looking at with Spoke, because that device is now smaller, let's start looking at our workers who are out, cutting grass on a 50-mile-an-hour roadway in the median. What happens when we start to connect them and make them visible to vehicles that are approaching, and looking at different ways that we can enhance safety for those types of scenarios. School crossings is another area that we're working on, because cities put out a lot of rapid flashing beacons. It's the ones where you walk up to a crosswalk and you have to tap a button to turn the light on. A majority of people don't touch the button. So what are ways we can use other sources of technology to recognize when someone steps into that crosswalk, and then actuate the light for them, while also broadcasting with the roadside unit the message out to a connected vehicle.
So how do you ensure reliability and the speed of actions in these systems to make sure they're safe?
So there's a series of standards that are already in place around the basic message sets that are used to communicate different types of interactions that have to happen. things called basic safety messages, for example. And these are pretty well established internationally. And again, just the fact that you have a message that's going out 10 times a second in confirmation of other sensors that are on the car or other vehicles, in addition to other opportunities that, that Brandon mentioned, such as LiDAR, begin to give a pretty clear picture of when a car is approaching a fairly dangerous traffic environment or something that needs the driver's attention. So it's pretty established, and I think that's one of the reasons why we're hopeful the Federal Communications Commission, along with the Federal Highway Administration in the Department of Transportation, will begin to accelerate the opportunity to deploy this on the roads.
So Brandon, Peachtree Corners has this connected infrastructure. How does that enable OEMs like Audi to test and validate these systems? Because you have a really great setup there.
Yeah, without the infrastructure, there's nothing for the vehicle to receive. So I think that is kind of the most important factor for us. And we knew that going in to really, start to push this industry forward, because we saw the benefits and safety for it that we needed to make sure the infrastructure was there. And then, we work with Brad and the team. What do they need to see from the data set side that helps them integrate into their systems? And that's kind of part of this beginning of the collaboration, to sit down and have those conversations, make sure the systems are communicating, they're communicating what they're supposed to be, and what's the most useful purpose of it.
Yeah, and also from our side too, if I can add to that, it's really important to understand what's the safety priorities of an individual city or sometimes statewide might be. So, for example, some of the issues that might be necessary to solve in Peachtree Corners might be different in a city where they're more concerned about how much time should be allowed for people in wheelchairs to cross the street, for example, near a medical center. Things like that. And that's where I think the collaboration is essential. So we both are able to look at the data and look at the individual problem that's trying to be solved and figure out how it works on both sides.
Well, this is a great project. Any last insights about what you're looking forward to next?
I think just continuing, to push the benefits of what the capabilities of C-V2X to have, to ensure the safety of all of our road users, not just those in the vehicle, but those that are out enjoying the multi-use trails that we're building, the bicycle lanes that we're building. Our job's to protect them the best that we can, and this provides a great opportunity to do that.
Yeah, and I would add this dynamic that we're talking about is something that's been envisioned since 1999. And I think, as I said at the beginning, we're at a real cusp of able to unleash this in very concrete ways and at scale across the country. What we're dealing with right now, since the FCC took away 2/3 of the safety spectrum in 2020 and gave it to the Wi-Fi industry, it's really not possible to launch 5G C-V2X in the United States because there's only 30 megahertz left. And we estimate between 5G and automated vehicle uses that piggyback on 5G, you're going to need at least another 40 megahertz of spectrum somewhere. So what we're left with, deploying here in the U.S., which actually coincides with how China is beginning to step into this area too, is LTE-based C-V2X for the time being. Now, we believe both at Audi and with 5G Automotive Association and a number of cities like Peachtree Corners that it's important to show progress with what we can put on the road right away, and then work with the FCC to unleash more spectrum as needed for these 5G uses in the not too distant future. But I just wanted to be clear that it's not 5G yet in the United States or even Canada, but it's something that we look forward to continuing to show progress towards in the future. And so I'm looking forward to the learnings that we get from Peachtree Corners and being able to help inspire other municipalities, other state DOTs, and road operators to envision what's possible and begin the process of installing the equipment.
Yeah, I realize this has been in the works for some time. We've been following this technology, and it's forward to seeing what you guys develop and come out within this project. So thanks, Brandon and Brad, for talking with me today. I know I've learned a lot about this project, so I'll definitely keep up to date on it. To our listeners, you can find more podcasts at podcast.microwavejournal.com. Thanks for listening.